In this redox question, the problem reads, an alkaline solution of permanganate and sulfite ions react to produce solid precipitate manganese 2 oxide and aqueous sulfate ion. So, we've written it out. The alkaline condition translates to the basic condition here. We always want to make sure we know whether it's acid or base. Sometimes it won't actually say so specifically in the question, but you'll notice that one of the reagents is either an acid or a base, and so that would be your clue. Okay, so we've written out all of the oxidation numbers. We've identified what's being reduced and what is being oxidized. For practice, let's identify the reducing agent. Remember, the reducing agent is causing reduction in something else. It itself is being oxidized. So the reducing agent is sulfur in the sulfite ion, and the oxidizing agent is manganese in its +7 oxidation state. And so manganese in the permanganate ion is the oxidizing agent. You see, it's an agent, so it's affecting the oxidation process in the other reagent. Alright, let's go ahead. Let's start with reduction this time. Reduction half reaction. MnO4- goes to manganese oxide MnO. In the oxidation half reaction, sulfite goes to sulfate. That's it. Manganese balanced oxygens. Are not balanced. I need 3 more. I'll add them as water molecules. I've introduced 6 H+, 6 hydrogens, so I'll add 6 H+ to the other side. Is it acidic? No, it's basic, so I need to add the same number of hydroxide ions to both sides. Oh, sorry about that. Let's move this. There we go. That's better. Sorry. To look up. And so that is effectively 6H2O. Let me fix the camera. There you go. Yeah, these are not questions that you want to tackle on a test when there's 5 minutes remaining. Make sure that you look through a test or exam, as the case may be, to find these. Maybe do them at the beginning so that you have time to do them, check them, and make sure they're correct. So everything is balanced here except for the charge. -1 on this side, -6 on this side. So I'll need 5 electrons. As far as quizzes go, for example, you could be given this either in Word or formula form, and the question might simply ask, balance the reduction half reaction. And that's where we've gotten to here. This is a balanced half reaction. This is balanced reduction half reaction. So now I'm going to do the other side. Another way to make a smaller problem out of these rather large ones would be to say, to ask how many electrons, the answer is right here, how many electrons are needed to balance the reduction half reaction? And the answer would be 5. 5 electrons on the left. So there are different ways that we can test your ability to do these without doing the full-blown question. So we'll move over to the oxidation half reaction. The sulfur is already balanced, so I'm just adding a water molecule, which I didn't draw yet. There we go. H2O. I needed 3 plus 1, 4 oxygens on the left to match my 4 oxygens on the right-hand side. I've introduced H2O, so I need to add some over here. I introduced 2. I need to add 2H plus. This is not an acid, it's a basic medium, so I need to add that same number of hydroxide ions, but to both sides. I'm just going to grab my other marker and put a little division line, boundary line here down my page. So I have 2OH minus plus H2O, sulfite goes to sulfate, and 2 water. On the left, my total charge is minus 2 minus 2 minus 4. And on the right, only a minus 2. And so I need 2 electrons on the right-hand side. Just in view. So now I have 5 electrons and 2 electrons. So I actually have to multiply this by 2 and this by 5 and add them together. And let's make more room. And we can see everything in view. So let's do that. So now I have 10 electrons transferred, lost and gained. 2 times 6, 12 H2O, and 2 MnO4 minus, plus, I'm over here now, 10 OH minus, plus 5 H2O, plus 5 SO3, 2 minus, goes to, I don't know if I'll be able to fit this all in one line, 2 MnO plus 6 H2O plus 12 OH minus, over to this side, plus 5 SO4, 2 minus, plus 10 H2O and 10 electrons. So it's a monster equation. We'll try and simplify it now. So my 10 electrons and my 10 electrons will go away. Cancel those. Let's underline everywhere where we have water. I have 12 here and 5. So I have 17 waters on the left. And I have 6 and 10, 16. So I'm left with 1 H2O on this side Not on that side, right? Because I had 17 and then 16. And I have 10 hydroxides on the left, and I have 12 hydroxides over here. So those will cancel. Oops. That'll go out with just the 2 left. Okay, let's be careful. So the 10 electrons left, I was left with 1 water, so that's H2O, liquid, plus 2 MnO4 minus, and we'll add our subscripts, that's aqueous. Those 10 hydroxides left, right? And the water is taken care of, so now I'm adding 5 SO3 2 minus, and that's aqueous. My arrow, 2 manganese oxide, solid, and then I had those 2 hydroxide ions, aqueous, 5 sulfates. Look at that, I put 2 plus, that's a 2 minus. 5 sulfates, and that's it, right? Because after that it was water and electrons. Okay. Oh, sorry, didn't look up. Shoot. Oh, sorry about that. Stupid camera. Okay. Let's make sure everything is balanced. Water. I have 2 hydrogens. 2 hydrogens. 1 oxygen, and then 2 4s are 8. 8 and 1 is 9. 3 5s are 15, and 9, 24. I have 2 oxygens here, 2 here, that's 4. And 5 times 4 is 20, so I have 24 O on each side. 2 manganese on each side, 5 sulfur on each side. Great. Charges, -2, and a -10 is -12. -2, -10 is -12. So we're balanced. Done. We know it's correct. Okay, so remember, this could just be the first half of a larger problem, and here the larger problem might be, you know, that we're mixing so many milliliters of so many molar permanganate solution or potassium permanganate solution with so many with a volume of so many molar sulfite, and predict the solid precipitate that comes out, something like that. That's a totally reasonable question. And we'd be ready to do it now. So you see how this stuff combines all of the stuff we've been doing in conversion, factor method. Okay.